Alrighty, hey everyone. So today we're going to be talking a little bit about triangles. So we're going to go over the different types of triangles and how we distinguish between them. So just a little bit of overview. There's two main ways in which we differentiate between types of triangles. The first way we do this is through angles. So kind of looking at how the sides of the triangles come together in angles, and then we use those to differentiate between certain types. The other main way that we differentiate between types of triangles is we're looking at the sides. So how long are each sides relative to each other? And we'll kind of talk about the different types that are associated with that. And then with these two different kind of typologies for the way in which we differentiate between triangles, we can combine the two and we can have certain examples that have a little bit from both. Then finally, we're going to go over some tricks to remember the two. So first, we're going to talk a little bit about differentiating by angle. So when we're looking at triangles, like I said before, we're looking at the way, in terms of angle, the sides come together to form angles. You can see here in this triangle, there's three angles that are formed. So when we differentiate by angle, we want to look at the largest angle that's formed within the triangle, and that's going to define it. So the first type is obtuse. And obtuse triangles is when the largest angle in the triangle is greater than 90 degrees. So we see in this blue triangle right here, the biggest angle is, can anyone tell me what the biggest angle in this blue triangle is here? Andy.
110 degrees.
Yeah, awesome. So 110 degrees. And because that angle is greater than 90 degrees, we call that triangle obtuse. And the same thing applies to our acute angles here as well, our acute triangles as well. So in acute triangles, the largest angle is smaller than 90 degrees. So in this triangle, can anyone tell me what's the largest angle? Cameron.
75.
Yeah, that's awesome. So 75 degrees, since that's smaller than 90 degrees, that's going to be an acute triangle. And then finally, our last type is the right triangle, in which the largest angle is exactly 90 degrees. And we see this in this bottom triangle right here, the purple one. And we see this angle B right here is 90 degrees exactly. And we can also tell this by the little square that's formed. So when you see a triangle and there's that little square there, that means that the angle is exactly 90 degrees. So the other way in which we differentiate triangles is through the side lengths. So there's three different types of side length triangles, three different types in which we differentiate triangles based on side. The first of which is equilateral. So equilateral is when all sides are the same length. And we can know this because of these little small red lines that are perpendicular to the main side lengths here. And when we have the same amount of notches here on each of these side lengths, even though we don't know exactly how long it is, that indicates to us that they're the same length, and we can say that this is equilateral. So in a scaling triangle, on the other hand, is kind of the opposite of equilateral, and that's when all sides are different lengths. And we see here on this scaling triangle that there's the notch marks that are in each of the sides, there's a different amount. And that means that they're different lengths. So even though we don't know the exact lengths, because of these little notches, we can tell that this is a scaling triangle. And then finally, we have isosceles triangles. And that's when two of the sides of the triangle are the same length. And right here, just as in the equilateral triangle, we can see these little notches that show us that they're the same length here. So now you can actually put this together, right? So triangles can be differentiated based on both angle and side at the same time. So one example of this is this triangle right here that I'm circling with my cursor on the left. So in this case, if we're looking just from an angle perspective, this angle right here is greater than 90 degrees. So that makes this an obtuse triangle. But based on the notches here, we can also see that the sides are all different lengths, right? So that makes it a scaling triangle too. So in this case, we would call this an obtuse scaling triangle. So quick review. What type of triangle is this? Andy.
An isosceles triangle?
Yeah, very good. So based on these little notches, we can see that these two sides are the same length, and thus it would be an isosceles triangle. And in this case as well, we can also tell based on the angles, all these angles are smaller than 90 degrees. And that also makes it an acute triangle. So in the grand sense of things, this would be an acute isosceles triangle. But great job, Andy. Can anyone tell me what type of triangle this one is? Cameron.
That would be an obtuse triangle.
Yeah, that's absolutely correct. So here we can see that the largest angle here is 114 degrees. And since that's larger than 90 degrees, that makes it an obtuse angle. And although we can't say this for sure, I would also assume that this is a scalene triangle as well, since the sides look different. Now we can't assume that since we don't have the notch marks, but something to think about. So this is likely an obtuse scalene, but we can only say that it's an obtuse triangle for sure. So finally, here are some shortcuts for how to remember your triangles. So we're going to start with differentiating based on angle. So we'll start with acute. So acute, kind of like a very cute angle, a very cute small animal, the largest angle within an acute triangle is smaller than 90 degrees, like this cute little animal. For obtuse triangles, obtuse, kind of like over, kind of a little word association there. The largest angle is over 90 degrees. So that's what you're looking for, kind of like going over a fence here, going over 90 degrees. And then finally, for the right triangle, the largest angle is just right. It's exactly 90 degrees. Kind of just like how, if you guys know the Goldilocks story, Goldilocks was searching for the just right bowl of porridge. And finally, for remembering the side lengths, we have for equilaterals, equilateral is very similar to the word equal. So we can remember this because equilateral triangles have equal length sides. And then for scaling triangles, kind of like an uneven scale, all of the different sides in the scaling triangle are different lengths. So like uneven, different, uneven scale, different sides. And then finally, the last one, isosceles. The beginning of isosceles kind of sounds like I, and kind of like how we have two identical eyes, isosceles triangles have two identical sides. Awesome. Well, we're running low on time, but thank you guys so much. This is very fun. I hope you learned a lot, and I'll see you later.